Hi there, everybody. As Brian said, I'm Josh Townsend, and by day, I'm Geospatial Strategic Projects Lead at BP, but by night, I am chair of an open source task force for the IOGP called GIGS. I've given this talk once before, and unfortunately, as much as I would like to be, I'm not going to be talking about going out on a night out to a gig. I'm not going to be talking about the one and only Ryan Giggs. I'm not going to be talking about legendary grime artist Giggs. And I'm definitely not going to be talking about the historic horse-drawn two-wheeled carriage, a gig, as everyone gets up and leaves. No, far more excitingly, well, for this audience, hopefully I'm going to be talking about the geospatial integrity of geoscience software. And thinking about it, we probably should have come up with a different acronym, but there we go. So GIGS, in this context, is a digital toolkit for verifying the integrity of your spatial technologies. And it's made up of test data sets, software development checklists, and industry best practice guidelines. We recently released version 2.0 of it late last year. And as I said, it's released fully open source, free to use via the IOGP. I think I'm preaching to the converted, but we can all agree there's this exponential rise in spatial thinking in our world. I came across this quote that says, "The volume and diversity of location data is exploding, the cost of acquiring and analyzing it is declining, and clever applications that create value for businesses and their customers are emerging." And if we look at the infamous Gartner hype curve that predicts the future, a lot of those technologies are spatial-based. And very good news for our pensions. The market value of geospatial continues to increase into the billions of dollars. And if we look in the software space, what we're seeing, I think you'll all agree, is traditional software vendors that wouldn't typically have previously involved geospatial data in their offerings start to put the map at the kind of front end of a lot of their services and a lot of their products. And with that then comes a variety of different options for computing your coordinates, computing your geospatial data. There's a few geospatial or geodetic engines I've put up on the screen there. Some open source, some commercial, hopefully some that you're familiar with. And of course, with all those different geodetic engines, there's also this wealth of different spatial products that we can derive from our coordinate computations. So pretty much everyone here, I'm sure, has created some amazing maps in Python, in R, using JavaScript. Something that keeps me awake at night is that you can create a map in Excel now. And I'd say all that glimmers is not gold. This is great. We've got all these options. But from my experience, the past 11, 12 years in the geospatial world, past 10 years in the energy industry, I would rewrite that quote as: the volume and diversity of location data is exploding, the cost of acquiring and analyzing it is declining, and bad applications that lose value for businesses and their customers are emerging. So I don't want to bring the vibe down, but I'm sure you all know terrible maps on Twitter. There are some pretty bad cartographic crimes being committed out there. I don't know who Terrible Maps is, by the way. If it's anyone here, I'd love to meet you. You're doing a great job. In my world, in the energy sector, in the geoscience world, there are also, unfortunately, a lot of bad maps. This is some screenshots I've taken over the past few years. Issues with coordinate reference systems, introducing errors of a few meters all the way up to a few 100 kilometers. Issues with precision, the lat and longs in the middle there being reported to the femtometer level, which is half the diameter of an atom. So we're good at positioning, we're good at surveying, but we're definitely not that good. Issues with scale, some horrendous looking map interfaces, and everybody's favorite, issues with transformations. So again, misusing transformations, a few meters, a few 100 kilometers. And I know we're talking about Brexit, but moving the UK 200 miles is not a good idea. And in my world, in the geoscience world, and in the hydrographic sector in particular, these failures can have serious consequences. These are some real-world examples. I should say none of them are from BP, luckily. But these are real-world examples of where there has been a significant impact from a failure in geospatial integrity. So top left, Lake Peigneur in Louisiana, completely drained because of a trilateration error with the drilling contractor. The Mighty Servant 2, the Sea Diamond vessels both capsized because of navigation and positioning errors with their online navigation systems. Just last year, the Shengping 01 on the far left, constructing a wind turbine monopile, collided with the monopile and was lost due to a datum error. A drilling contractor drilled through the Paris metro recently because of an issue with coordinate reference systems, and then countless examples of jack-up failures, punch-through, structural failures. Someone here drilled through a telecoms cable, and all of these, the root cause has been bad spatial data or bad spatial technologies. And again, preaching to the converted, but that is bad for business. So there's those obvious impacts of safety and operational risk. That's the primary thing we want to avoid. Then there's costs, fines, reputational damage, legal implications, lost time in putting things right. Nobody wants that. And I'm sure we've all come across these common geospatial pitfalls that can cause those things. So a lack of exchange standards, which Lisa's going to be calling out pretty soon, a lack of geodetic metadata with our coordinates, confusing terminology. Is it X, Y, is it Y, X, is it easting, northing, is it westing, southing, is it latitude, longitude, is it longitude, latitude? Who knows? Incomplete or incorrect CRS parameters and transformations. If you've ever brought in some data and it's gone a 0, 0 over the infamous null island, then you've fallen a cropper to that. And then poor documentation as well. And there tends to be a lot of inconsistency between applications. So there is a website which I don't endorse, ihatecoordinatesystems.com. I feel personally attacked by it, but it is a problem in our discipline. And so to avoid all the stuff we've just seen, we need to have geospatial integrity. And geospatial integrity is more than just the accuracy of your underlying coordinates. It's all this other stuff. It's the user interface. It's your geodetic data object library. I'm concerned about the geoscience world, so I also care about seismic data and well data. Most people don't. But it's more than just the coordinates. And to have geospatial integrity, all of those elements on the left should be complete, correct, consistent, and verifiable. We probably should have come up with a fourth C as the bottom one there, but there you go. 3 C's and a V. But all hope is not lost. Remember, we can use GIGS as an open source digital toolkit for evaluating an application's ability to establish and maintain geospatial integrity and data quality, or GIGS is just a good way to trust that your software is putting location data in the right place. And the idea with GIGS then is you input your code. So you input your source code, you input your application, you run the GIGS tests, which I'll show you in a minute. You output some results, and you get generated some scores and some benchmarks, and then you iterate the build of your software based on the results of those. And you can scale the GIGS tests, so you can just do a few tests, or you can rerun them every time your software build changes. What do you get out of the box? The GIGS package. You get some documentation, a user guide, and a guidance note. Tells you exactly how to do the testing. You get some test series, which are the actual checklists themselves. So there's about 200 questions that you answer. You can do that online or an offline spreadsheet if you like to work that way. And then there's the actual test dataset package. So this is a huge compendium of test data. We offer it as a base class ASCII format, but also P files. And then we offer it via the Geo API as well. And then we've got quite an active GitHub where you can collaborate and manipulate our source code. And then everyone's favorite, a media pack as well. So GIGS has actually been around since 2007. It was a joint industry project by these guys to address some of the spatial integrity errors that were being seen in the energy industry. And then I chaired a task force 2 or 3 years ago to re-release it, modernize it, improve it. We've worked to make it open source with the OGC, and you can see people contributing here. All of this is voluntary, so Sunday nights, Friday nights, that sort of thing. We've had quite good uptake so far with traditional geoscience software companies, you could say, but we're kind of looking to expand the usage into the spatial data science world as well. And the idea is you do a quantitative evaluation and a qualitative evaluation. So you quantitatively assess the integrity of your geodetic engine, but you also qualitatively assess the integrity of your user interface or your help documentation. And then, obviously, you want to ensure that your geospatial implementation is complete, correct, and consistent and verifiable. A wall of text. But these are the themes that are covered by GIGS. So we cover coordinate reference systems, we cover the user interface, cover your parameter library, seismic data, transformations, conversions, map projections. And if you log on to the GIGS site, you can make an account and put in the applications that you're testing. You see the card there. You click on a card, you get to see the progress against those test series that I just showed you. And then you get given these scores. So you get given a level, basic, intermediate, advanced, and a score as well to show how well your software is performing. The test series themselves look like this. So you've got a drop-down criteria, and you select the criterion that most closely corresponds with how your software performs, and then that gives you a level. So you select a criterion, and you get basic, intermediate, advanced. And then all of that gets added up, and your score gets totaled. I mentioned the test data. So this is 10,000 test points from operations all over the world, and it's test points for conversions, transformations, but we also have synthetic wellbore data and synthetic 2D and 3D seismic data as well. The test data itself is actually quite boring. It's just input coordinates and output coordinates, but it's all in this common ASCII format, so it can be programmatically ingested. And we cover all these weird and wonderful projections that you might not come across, some that you might know, Mercator A, Mercator B. But yeah, we tried to cover this whole envelope of possible projections and geodetic scenarios. If Java is your flavor, then you can run it automatically for a JUnit package, or you can run it through the OGC Geo API. And the output is an automatically generated PDF report that shows you exactly how your software has performed in each test and what you might need to improve. And there's lots of help documentation to help you as well. So you can head onto the website, you can download it, or just get it all from the GitHub. I think as a community, we're quite bad at self-certifying our code. So in the digital world, there's this idea of test-driven development where your code is guilty until proven innocent. In the geospatial world, I think we tend to assume a lot of our code is innocent to start with, but what we're seeing now is vendors and purchasers and users of software start to ask for these certifications, like gigs, for example. And the idea is that we want to encourage gigs to be embedded in your standard unit tests and your integration tests when you're developing software. Gigs is also integrated with a lot of other geospatial initiatives. So I'm sure you all know EPSG, infamous EPSG codes. EPSG is managed by the IOGP, of which GIGS is part of. So GIGS is really closely aligned with EPSG and then the other IOGP stuff as well. But then we also support the adoption of many ISO geographic data standards. We work closely with the OGC and the OSDU as well. So it's all open source. And yeah, we really encourage kind of manipulation and uptake of the code. So to close then, again, I don't need to preach to the converted, but geospatial integrity is good for everyone. When you have it, things are more efficient. So you've got operational efficiency, you've got digital efficiency. You're not having to repeat work. Let's say you go out and drill a well on the wrong datum, then you've got to go and re-drill that well, and you're going to use and produce all of those emissions. You're going to consume energy, time, expend resources. So doing things right the first time is obviously good. We need to mitigate against those risks. So there are real issues and consequences of geospatial integrity failures. We also have collaboration. So geospatial integrity enables collaboration in this world of big data, of cloud computing, of data lakes. When we're all kind of singing from the same geodetic hymn sheet, it's a lot easier to amalgamate all of that data. And then we also reduce errors and have faster development times and an improved user experience. So it's happy days. So I'd say start trusting your spatial data, but yeah, prove it innocent rather than guilty. That's the website there. Thank you very much for your time. I really appreciate it. And yeah, happy to answer any questions.
I don't want to make a bad joke, but that was a record amount of giggles in a spatial data science conference.
I like to bring some energy to it.
The geospatial banter was really up there. Thank you. Has anybody got any questions for Josh? In the middle, this gentleman here.
Hi, Josh. Excellent brief. I'd never heard of it, been in the industry 27 years, so I'm going straight to it.
Right, I've been doing my job right then for a few years.
Yeah, what I want to know is there a hidden slide that's got the league table on it with all the applications that we're all using?
Damn, I knew I should have bought that. So the gig site, to make it open source, we've committed that it's entirely encrypted and self-enclosed, so I never get, or any of the task force ever get to see anyone's results. If you want to share it, you can. Maybe we need to do like a winter cup or a summer cup or something. But yeah, it's all fully encrypted, it's all fully secure, so who knows? No one's going to confess, are they, if they get a failure? So yeah, thanks for the question.
I think just behind you. There we go.
Hello, thank you for your presentation. I'm a very poor GIS analyst, first time in offshore industry. So now I have to deal with, I don't know what ESPG to use for which part of
Yeah.
the ocean, what the heck is MLW, and then what is different in the US, different in the EU.
Right.
Do you have like official list of what I should refer to when I
Right.
work?
So if you head on to the EPSG, which has over 1 million search hits, I should say, and if you go to this map search here, you can draw a polygon of, or a point of the area that you're operating, and it will give you a complete list of coordinate reference systems and transformations that you use in those areas. And then if you click on each entity, so each coordinate reference system, it will tell you the relative accuracy and also the scope and the purpose. But if you've got a particular field that you're working on, you can also search for it in here, and it will come up with the recommended CRS. And I think that's just epsg.org, I think it is, or just Google EPSG.
Cool. I think we've got a question at the front.
This is great. I always look for direct references. So there's a couple of questions I wanted to ask you. I mean, I guess as we work out, I'm looking at the interoperability through GeoParquet. And obviously, this is coordinate systems, one of the biggest issues that you find in there. But OGC has done a lot of work on that one and standardization. But one of the things that we see is that different data warehouses and lakehouse and so on now are implementing different different systems for storing the geospatial data. So in some cases, kind of like more geometry, and others more geography. And we are trying to standardize that actually to a minimum, so that like the vendors explicitly say, I mean, what do they support and how they are. So they're starting to do some, like you said, like transformations between them under the hood that sometimes can be pretty. So that's one issue to look at more as a comment, because I think we're gonna face that a lot over the next at least 2-3 years, because there's not, that's one thing. The other I wanted to ask you is about the issues with coordinates and timestamps, right? So how big is the issue? How much, how are you, well, if you can maybe comment around it, because I know that you guys work a lot on that. And I mean, how serious we should take the issue now, especially since a lot of geo is now being recreated in a lot of products, if this might be a good opportunity to tackle that.
Right, yeah, two solid questions. So the first one about GeoParquet and lake housing and data lakes. I think particularly topology, things like JTS as well, we're seeing a push for really amalgamated data sets being presented, stored, and manipulated on Earth-centered, Earth-fixed coordinate reference systems or global systems like WH84. So I fully support that, and I fully realize that that is essential to doing spatial data science on huge global data sets. But my ask, or my kind of preference there, is that we store the original geodetic parameters that a lot of this data has come in, and we do those transformations, but we assure the integrity of them. So it's fine that we put everything in WH84 or ITRF or some ECEF system, but I still want to retain that original metadata to know what those coordinates were acquired in and what transformation was used to get to WH84, because then if I need to go back, I can get that, and I also know the accuracy of the transformation. Your second question was about dynamic CRS, I think. So at the moment, for a lot of data science applications, it's not a huge issue. Yeah, so dynamic, all the coordinate reference systems we work with currently are static, so they're attached to tectonic plates, essentially. With dynamic CRS, we start to consider time dependencies and epochs, so we realize coordinate reference systems at a point in time. And this becomes important in places like Australia, where the plates are moving pretty quickly, and our fixed references are moving away from each other. So in the industry and in the discipline now, we're pushing to have coordinates realized with a timestamp with an epoch, so you can relate them to a particular realization. I don't think it's a problem for data science yet. I wish more vendors would do it. It becomes a problem if you're doing engineering design in Australia, for example, again, or some elements in the Northern Hemisphere. But I would say probably learn what it is, but I don't think it's an issue now. Yeah, thanks.
Cool. I think we've got time for one last one.
Just because it's come up a few times today, and because I'm fairly new to this, so apologies if it's a stupid question, but why isn't there a Z-axis? So like, we talk about things like, they're drilling into the Paris Metro and stuff, or they're, looking forward to the next 10 years when you've got drone delivery, different floors of buildings and all that kind of stuff. Is there a standard, or is there a standard in the future to then cope with that kind of, the layers of things,
so I mean,
height?
Yeah, vertical is often the kind of unloved child of geodesy, but there are ways we can promote that and deal with it. So we've got the VORF in the UK, for example, vertical offshore reference frame. But some of these examples here are due to vertical datum errors. So the Mighty Servant 2, the vertical datum was set incorrectly, and she hit a sandbank that was essentially lower. So thank you. Z is important, equally as important as X and Y.
Brilliant. Thank you so much, Josh.
Thanks,
That
Lawrence.
was a really great
Cheers.
talk. Thank you.
Thank you.